You're listening to ReachMD, and this is Dr. Matt Birnholz. I'm speaking with Dr. Mark Hanson, Director of the Academic Unit of Human Development and Health at the University of Southampton in the United Kingdom. Dr. Hanson has focused his work on new ways to reduce disease processes and improve health by championing preventive interventions from preconception through pregnancy and beyond into childhood. In his recent lecture, The Developmental Origins of Health and Disease, or the DOHaD Challenge, he talked about why investing in the health of our current generation is the best way to invest in the health of future generations. Dr. Hanson, great to have you with us.
Good morning. Very nice to be invited, Matt.
So, Dr. Hanson, to start, can you give us a background of the DOHaD Society and just DOHaD in general and what you and your colleagues are addressing?
The DOHaD Society started about 15 years ago as a result of observations that showed that early life, particularly maternal nutrition and growth in utero, so birth weight as a crude marker of that, were linked to later risks of non-communicable disease, high blood pressure, type 2 diabetes, some forms of lung disease, even some forms of cancer. This was an absolute revelation at the time because it was thought that these diseases, the so-called non-communicable diseases, resulted from a combination of genetic predisposition, that you inherited risk, if you like, from your parents, and adult lifestyle, smoking, poor diet, lack of exercise, all the things that we know so well about modern society. And over the 15 years or so, these risk factors, genetics and these environmental things, have all rather faded into obscurity because people have realized that actually they don't provide the answer. The genetic risk is pretty small for many of these diseases, and in fact the attempts to reduce the impact of the diseases by changing diet and lifestyle and so on have had a fairly small effect. So everybody was searching around for the answer, what was missing in the story, and that's really where the DOHaD concept came in.
You know, Dr. Hanson, one of the key sentiments that I see being expressed through DOHaD is a perpetual tardiness in addressing developmental diseases along the life course, and in many instances tracking the wrong life course by ignoring, maternal and paternal determinants of risk factors in childhood disease. What are your thoughts on that?
I think that's absolutely right, Matt. I think in some ways the perception was that because we weren't finding a way of treating these diseases, let alone preventing them in adults, people who many of them already had the diseases or had a high risk, that somehow we ought to just try harder doing that. We ought to force people not to smoke, force them to exercise, tax unhealthy food, provide free gym subscriptions for disadvantaged kids and things like that. And none of these things were working. And it took a long time for people to take a step back and say, hey, the reason that you end up maybe in middle age with a disease that's developed slowly throughout your life is not just what you're doing now, it's the path you've taken to this particular place. So maybe we need to take a step way back and think about the early life factors that lead to that risk of disease. And that's really the sort of life course idea that I think is getting some traction now, but gosh, it took a long time really to be accepted.
And why do you think that there was such an impediment to moving in that direction? And why was it so difficult to come into that wavelength of thought?
I suppose there were a couple of reasons, really. As a medical community, of course, we wanted to carry on doing what we thought we were good at doing, so treating adults with obesity, with diabetes. Nobody perhaps wanted to accept that disciplines like obs-and-gynae and even paediatrics and neonatology, which are perhaps Cinderella disciplines, maybe should have a bigger role. I think there's another reason too, which is to do with sort of fashions in science. And of course, in the 1990s, all the emphasis was very much on the Human Genome Project, and the idea that once we understood the blueprint that would make a human being, make us different from our nearest relatives, the chimpanzees, then of course we could find the little tweaks and mutations and things that had gone wrong in the genes of some individuals that led them to risk. Fantastic achievement, the Human Genome Project. I'm not knocking it, but the trouble is it didn't pay off in terms of finding the genes for these diseases. And so, once again, we had to take a step back and think, okay, so what are we missing here? It's not just the genes, it's something else. And that's really where the developmental environment came in, because the simple observations that a low birth weight baby, or indeed a very high birth weight baby, has a much greater risk of diabetes or hypertension in adult life, suddenly made people realize, well, that developmental environment, that whatever it is that's led to the change in birth weight, must have an important role.
And actually, on this topic, you've spoken some of the problems of trying to track genetic causes of disease and the determinants of disease, and how there's a need to shift some of our focus to epigenetics, and how late we've been to that party, as it were. perhaps epigenetics can better inform us of the ways that environment specifically influences risk of disease. What can you tell us about that?
Epigenetics is the new science, really, of how environmental factors, in the loosest sense of the term, impact on the way that genes work. So they don't affect the genes that we've inherited, if you like, the DNA sequences in our genomes that have come from our mums and dads, but they affect which genes are turned on and when and for how long and so on. So we've known for probably half a century or more that these things are important in the way that we develop. Obviously, we develop a whole range of different tissues and organs from one single zygote way back. So every cell theoretically has the same genome, and yet many cells, of course, end up looking different and functioning in a different way. So we've known about epigenetics, but it took a long time for us to realise that it was the way in which environmental factors can influence epigenetic processes, can then go on to influence the way that genes are switched on or not, and then alter our risk of disease. That's the thing that took us a long time to realise.
It's almost an unbelievable concept to many of us to imagine that a single change in one methylation group can lead to tremendous changes in health trajectories, such as in cases of childhood obesity and diabetes progression. What can you tell us about that, and is that not simply speculative fiction?
It certainly sounds like it, doesn't it? And I think it's extremely important in studies like this that the findings are replicated not only in the same cohort with different individuals, different ages, but other cohorts as well. And the trouble, I think, with the field is that we're realising, on the one hand, just how simple it is, that it might be just one methyl group at one CpG dinucleotide, as we call it, that can tweak the expression of a gene that has a major impact on disease risk. But then on the other hand, there are millions and millions and millions of these CpGs in the genome, and it's probably going to be some sort of pattern, like a fingerprint of how these epigenetic marks are placed, that's going to lead to the change in phenotype. And so where we realised that we needed some powerful computers to deal with the human genome in terms of fixed genetic mutations, now we realise that we need computers 1,000 or 10,000 times more powerful than that to deal with the problem. I work in the University of Southampton, where we have one of the fastest computers, certainly in the United Kingdom. This thing runs overnight and still sometimes crashes, and then you must make you stop and think, are we asking the right question here?
Well, I think what you were talking about leads well into another subject that you seem to have great experience in, and that's this idea of intergenerational passages of risk, of which the study of epigenetics might be helping us understand much, much better than before, specifically the cycle of disease determinism. Can you talk about that and this intergenerational passage of risk?
We've known for a long time that some patterns of disease get passed from parents to offspring. And actually there's been a bit of data out there for some time that these patterns can even be passed from grandparents to grandchildren. But it was a large number of animal studies, I think, that then showed the mechanism by which this passage can occur, that it can be via an epigenetic change, either in the ovum, the egg which goes on to be fertilized to become a person, or indeed in the sperm that can be passed from one generation to the next, and that in fact these changes might even pass, certainly for the ovum, from the grandparents to the grandchildren. The sort of environmental challenges that led to this were things like diet, body composition, exposure to stress in warfare or starvation situations, things like the siege of Leningrad or the Dutch hunger winter. A huge amount of science has now been done to show that these processes really do exist, and they're much bigger than we thought. And so we're beginning to realise just how the kinds of things that we do today will not only affect our own health, they'll affect the health of our kids, they'll even affect the health of our grandchildren. And that really does make you pause for thought and think, well, we really have to be so careful about the environment in which we live. One of the things we heard of actually at this meeting was the effects of toxic chemicals, endocrine disruptors as they're called, which can again tweak these epigenetic processes and alter not just sexual maturation and brain development in a range of animals, including us, but also risk factors for non-communicable disease.
And in concordance with that, the idea that exposure does not necessarily need to lead to impaired health outcomes in the direct population, but perhaps in generations beyond that, as you're indicating with your studies through DOHaD. So the billion-dollar question then comes up. How do we begin to address breaking that cycle of disease determinism?
Yeah, that is the big question. Of course, we've given it a lot of thought. And in a nutshell, I think the conclusion that we're beginning to come to is that, of course, the earlier you start, the more chance you have of getting success. And so a lot of the focus around the world now is on adolescent health, trying to make boys and girls in a healthier state actually even before they conceive a child, so that this will be good for them, but it'll also be good for the next generation. Not easy, of course, because adolescents are by and large healthy, and they're by and large not that interested in their health. They maybe understand the issues, but think, yeah, sure, but I'll put it off till tomorrow. I've got other things to worry about right now. I want to get a good education. I want to get a job. I want to buy these trainers or the new iPhone or whatever it is. So actually getting on the same wavelength as the current generation of adolescents and saying to them, look, you need to think about your health as a long-term thing, and you want to have a family, and most adolescents I talk to say they do, so you want to think about the health of that family too, and the sooner you start to lead a healthy life, the better. It's not easy because most of the campaigns that have tried to promote health education in schools have not been terribly effective. Sometimes they make things worse. We obviously can't depend on parents necessarily to communicate the right information to their children, especially some of the disadvantaged groups of the population that are hard to reach and at high risk. So we're beginning to think more and more that we need the right kind of collaboration between doctors and researchers, teachers, community workers in a community setting, probably outside school, trying to make the science fun and the health issues fun. So we're not preaching and teaching, but just trying to bring adolescents who are pretty smart actually, aren't they? Who can change their views very quickly onto the same page as we are.
If you're just tuning in, you're listening to ReachMD, the channel for medical professionals. I'm Dr. Matt Birnholz, and I'm speaking with Dr. Mark Hanson. He's director of the Academic Unit of Human Development and Health at the University of Southampton in the United Kingdom. And we're talking about the developmental origins of health and disease, or otherwise known as DOHaD challenge. I think you have a very good experience and recognition of the relative merits of school-based educational initiatives and how they measure up and whether they actually make a dent at impacting behaviors, especially health style modifications. It sounds like they don't quite do the job compared to perhaps more innovative interventions that are outside the classroom. Is that correct?
That's what we're beginning to realize. And of course it does require innovative ways of engaging with adolescents, many of whom, as I say, are fundamentally healthy at this time in their lives. It's also important because in this particular Congress, of course, we've got lots of OBGYN people whose job is to deal with women and their partners who come in and say, look, I think we may have conceived a child, I may be pregnant. That may be the first time in their lives when they actually met a healthcare professional and really engaged with some of these issues. And it's critical that we don't miss that opportunity. They'll be scanned and monitored several times during pregnancy. They'll have advice about breastfeeding and how to look after the newborn baby and so on, and they'll be thinking about the preschool years. This is a wonderful opportunity to get health messages in, not only for these young parents, but also for their kids.
Why don't we spend a minute or two, even though one could spend an entire lifetime or a career on this subject, talking about paternal determinants of intergenerational health, which doesn't often come up as much. There are a number of misconceptions about paternal determinants when we think of the epigenetic factors for health of newborns, infants, and children later on. But put another way, do the sins of the father have a significant impact here?
They certainly do, and you were actually in that title quoting from a review in Nature, which it's certainly worth looking at. We used to think that the only thing really the father contributed towards his offspring at the time of conception and throughout pregnancy was just his DNA. The sperm had nothing really much but DNA within it. There was no, the head of the sperm had not much but DNA within it, compared to all the nurturing and feeding that goes on in utero, the role of course of the mother, and then breastfeeding. The idea was really that the sperm contained nothing much but DNA. There was no cytoplasm in it, and that the DNA in the sperm was so compacted, if you will, that any of these epigenetic tweaks that I've been talking about couldn't really be passed on to the next generation. Some people even said they were wiped and then reinstalled in the early stages of embryo development. All those things are now wrong. We know that there's just enough cytoplasm in the sperm to have a few strands of things called non-coding RNAs, microRNAs, which can affect DNA expression in the early developing embryo, and given that the embryo goes on to make the whole body, maybe there's an echo of that throughout life. We know that the epigenome isn't wiped at fertilization and then reinstalled, and we know that the DNA isn't completely compacted so that some epigenetic marks don't persist. Some do persist, and they seem to be in particularly interesting genes that control growth, metabolism, and cell maturation. it looks as if nature hasn't missed out on the opportunity to get some information passed from one generation, not only via the mum, where of course she's doing a lot of education of the offspring before it's born, but also from the dad in the sperm, which raises all kinds of questions about father's lifestyle, what he eats, whether he's obese or not, does he smoke, is he exposed to toxic chemicals, all really hot issues that we're talking about here in Chicago, and issues that are just not going to go away. We've got to resolve them in some way if future health is to be optimized.
It brings new meaning to the term, we are what our father and or mother ate, I imagine.
And indeed we are what our grandmother and grandfather ate and how they behaved and how they lived. Frightening prospects in a way, but kind of ones, when you talk to many members of the general public, as I'm sure, of course, your listeners do all the time, they'll say, yeah, but we know this. It's just that we were always brought up to believe, well, it's just purely genetic or it's purely environmental in terms of I smoke because my father smoked, my grandfather smoked and so on. Now we're beginning to realise there's actually a biological substrate for some of these things passed on from one generation to the next. It's giving us a new concept of inheritance, and not just of how we are, whether we have fair hair or blue eyes or whatever, but also the diseases that will actually sadly carry off more than 2/3 of us throughout the world, these non-communicable diseases.
Well, before we conclude this conversation, I want to turn our attention back to the DOHaD Society, or Developmental Origins of Health and Disease Society, and get your sense of what the call to arms might be from that society towards the general medical population and the OBGYN population, specifically for addressing some of the issues that you've outlined here today.
That's a great question. Thank you, Matt. There's no doubt that we need to work together on this. There's no simple, quick fix. There's no magic bullet. We're not going to find a drug or even a surgical technique that's going to take this problem away. It has to be a war which is engaged on multiple fronts. It requires, I think, the reproductive health doctors, the fertility doctors, the family health care practitioners to help young people to understand the importance of lifestyle even before they become pregnant. It clearly involves the obstetricians at the time that a couple have conceived in helping that pregnancy to be as healthy as possible, and the neonatologist and the paediatrician after the baby's born. But on a more general level, I think it really is beholden to all of us to engage more in society with school teachers, with community leaders, to try and make the world a healthier place, where health literacy, as we call it, the idea really that you can gain enough knowledge about health issues to make your own decisions about what you want to do, is something that's really promoted. It's a big challenge, but it's one that we can't get wrong, because the sheer costs of these non-communicable diseases, not just in countries like the US, but very much in transitioning societies in the developing world, are just going to be absolutely astronomical. And we can't afford to get this wrong. It's just that we don't have a nice medical model for it. We're used to a diagnosis and then a variety of treatment options. We're not very good at prevention of disease, with the exception perhaps of communicable disease, where it's either something you catch, you have it, or you don't have it. We know perhaps the vectors, we know how it's transmitted, we can think of ways of stopping it. Much more difficult with diseases that develop over the course of a whole life in individuals, and which are then passed from one generation to the next.
Well, Dr. Hanson, it's been a pleasure having you here today. Just for our listeners' sake, because promoting and getting a wider awareness of the DOHaD Society is so important, tell us where listeners can find out more about this particular society.
So if you just Google us or go to DOHaDsoc.org. You can find us on the web. It's a society where we encourage healthcare professionals and those interested in the issue from all walks of life to join.
Well, I hope for the sake of future generations, you'll have many, many new registrants after this particular conversation, because it's a wonderful society and amazing work that you do. And we're so thankful that you're examining some of these novel mechanisms by which we can attack chronic and acute diseases that normally aren't thought of as preventative in nature. It'd be wonderful if we can really examine some of the epigenetic and other environmental to genetic influences that relate to health determinism over time. I'd like to thank our distinguished guest, Dr. Mark Hanson, Director of the Academic Unit of Human Development and Health at the University of Southampton in the United Kingdom. Again, Dr. Hanson, thanks so much for your time today.
Thanks very much, Matt. Very good talking to you.